really glad to meet Tal and hear more about Orbs here because I know our readers eat this stuff up and they're going to love hearing more about it. Um, we noticed, the branding and the design is very sleek. It seems to be user friendly. But in your opinion, how does it differ from the Microsoft Azure platform or the AWS blockchain capabilities, or even from the Waves platform or other cryptocurrency based projects that seek to cater to businesses?
So first of all, if you look at the Azures of the world and the Hyperledgers of the world and the Quorums of the world, I think most of them, when they try to cater to the business world, they go about having a private blockchain or a permission blockchain. That means that you don't have anonymous validators trying to, verify what you're doing. For example, the apps themselves, whether it's Walmart, they operate the nodes. So you have some sort of consortium usually. And I think that this misses out on the disruption of trust of blockchain. Because the big idea in my eyes, the big innovation, the Bitcoin showed us is the fact, like what happens in trust when you don't have to trust anyone. And so trusting a consortium is better, I would say, than trusting one entity. But having to trust an incentive model, a permissionless incentive model is the best. That's like the ultimate level of trustlessness. Kind of like the difference with Libra. Libra is a little bit better than other things because it's, supposed to be 100 companies, but having anyone could validate, that's even better. Like that's the highest form. So basically what we're trying to do is bring the highest form to businesses today, and this is quite difficult because, there are many things with public blockchains that don't really work with regular businesses.
Definitely. You bring up a lot of good points there, and you spoke about the partners, and I lost my train of thought. But you guys have several different partners, or quite a few different partners. Names like Bittrex and BitThumb and Upbit, and even the World Economic Forum, excuse me. How do these different partners use Orbs to increase their business capabilities?
Well, I think usually the partners that you've mentioned are not really customers. They're ecosystem partners. Through them, we reach other areas where blockchain can do good.
Gotcha.
Unfortunately, the market is still very young. If you go around and you ask a company, and our business people are in Twitter's offices every few months, and you ask the Twitter guys, for example, are you looking at blockchain? What are you considering to do with blockchain? They would tell you, we have no idea. Like, we see this technology, we understand that this technology is disruptive, but we don't really know what to do with it tomorrow. And if you look at the projects out there, I would say that most of them are not very impressive. The projects are aiming pretty low. Like the cryptocurrency projects are crazy, but you don't see the real businesses, going that way. And if you ask me, like, what is the interesting question that we need to ask ourselves is, what do a company like Uber do with a public blockchain? Like, what is the value proposition? And the answer could be they don't need it. But I don't believe this is the case. And I think that the value proposition is trust. I think that if you look at the world around us now, you see that in this, internet economy of winner takes all, information hogs and these giants that control ecosystems, trust is a huge, huge issue today. You see this in Facebook, you see this everywhere pretty much.
Yeah.
And everybody is kind of helpless around it. The regulators are helpless. They don't know what to do with fake news. Adding regulations around it doesn't solve the problem. I've seen just recently a law from China that deep fakes, the AI videos are not allowed. Fine, like, how are you going to prove that these are deep fakes? Like, okay, try to regulate this. Or you see the regulator mumbling with stuff like the GDPR. They want to control users' data, and they have these weird laws that are, the impact that they did is just added a lot of pop-up boxes in all the websites that you visit. But the impact is very small. And these companies are kind of helpless, because if you look at every talk that Mark Zuckerberg is giving in the last 2 years, it all says, we care about user privacy. Like that's the only thing that he talks about, but nobody believes him. And naturally, because they're incentivized to do the exact otherwise. And there's no way around it. So I think that these companies have a huge issue with trust. And if you look at what trust solutions are out there, I think that, you know, the avant-garde Web3 went a little bit too far. You know, let's break down the entire internet, build a new internet that is, you know, without any corporations. I think that's a beautiful dream, but that's not going to happen. You know, let's be honest with ourselves. Like, you can't compete with Facebook with a decentralized business something. You know, it's going to be too hard. You know, all those ICOs that tries to raise money to do a decentralized Uber over, you know, like 2 years ago, they failed.
Yep.
So this is too difficult. If you want to do impact, you need to go to these companies, go to Uber, Twitter, and Facebook, and explain to them that they can use blockchain to regain trust. And I think this is the interesting value proposition. This is exactly what we're trying to do.
And you're right. There's so many big corporations out there that do know that blockchain is here. It's here to stay, and it can be a game changer, but they have no idea what to do with it at this point.
And building a consortium is not it. Personally.
No. And one thing that stands out to me with Orbs is the fact that developers can launch virtual chains using familiar languages to do so. And how are the developers reacting to this key feature?
So this is, you know, one of the big problems I've seen. And you know, one of my previous positions before Orbs, I was the head of engineering for Kin. And, you know, this was a regular business company. You know, Kik existed for 10 years before they tried to do Kin. And when they went into blockchain, we had to teach a lot of developers Solidity and Ethereum. And that was difficult. You know, all these languages, these new languages, they are complicated and the barrier of entry is too high. And the main thing that it does is, you know, it does create a small clique of crypto royalty, you know, very, very sophisticated people that can build these things. But it keeps it out of the grasp of the, you know, all the other developers out there. And I personally believe is that if you want to gain adoption, it needs to be simple. It needs to be easy to learn. You have to use existing languages. You can't go around inventing new languages like Solidity. You know, it's going to be very hard to gain traction this way. So this proved very successful for us. You know, for us, we actually do workshops with companies. And we go and we bring, you know, our own architects to sit with them and build a use case to show them the value with their own eyes. And one of the cool things that we're able to do is within 3 days, we can build a fully working proof of concept use case where their developers learn the system and develop on it all in the same time without any blockchain knowledge beforehand.
Right.
And to be there and show them, you know, that in 3 days they can build something that actually works on this magical technology that nobody understands. You know, this is the biggest proof that this technology is here and they can actually use it. So the challenge, I don't think, is that technology is complicated. I think we are already overcoming this. I think the challenge is the business use case. Is can you go and articulate to Twitter why the hell they would need to use something like this? And this is actually something I've been breaking my head around for a very long time, you know, to have this good, you know, pitch or value proposition to Twitter. So I want to try it on you and you tell me if this sounds convincing or not. So you know, like, what is Twitter's biggest problem today? And when you ask them, what is your biggest pain? They would tell you fake news. Network health, they call it. They have a huge problem with it. The fact that anyone can create profiles and the fact that anyone can say anything, that you have senators or, you know, other people creating profiles in their names and tweeting in their names. And it's very difficult to track and you can sway public opinion. You know how easy it is. And, you know, this is, you know, a weapon against modern democracy, this thing. And honestly, they don't know what to do about it. So as you know, they try to do those blue check marks on selected profiles. Now, this is a huge liability problem because what do? They have like their own people going around and checking the credentials of others. And this is a huge liability. It's very expensive. They do it for a very small number of profiles. Now, do you think that they do this for the Congress people of my country? Of course not. Like, they don't get there. So can somebody impersonate the Congress people of my country? Yes, easily. Like, and they can do that in the US as well. And Twitter doesn't know how to scale this. So one of the solutions that I've been thinking about is how can we give them a solution, to combat those fake profiles effectively with blockchain today, not in 5 or 10 years.
Right.
So the solution goes like, go to, for example, to a phone manufacturer, for example, Samsung or Apple iPhone. And have that company, whenever, like, give the capability of signing the photo that the phone generates. So they would embed some sort of, like inside the hardware of the phone, every time you take a photo, they would sign it and put the timestamp of where this photo was taken. So this is a technology that is not space age. It's relatively easy to do, and they can embed it tomorrow. Now, what you could do with blockchain is put, this authenticated photo on the blockchain and have a proof, that the pixels that you see in the photo have not been manipulated. You see the hash and you can see the timestamp. And Twitter, for example, can use such a feature to do automatic profile authentication without any liability. So how can they do that? Let's say that you want to authenticate your profile. It would tell you, go take a photo of yourself with your phone right now in the next 10 minutes. You would take that photo, it would be signed and hashed on the blockchain. They would use this proof to say that this is your official photo.
Right.
And anyone who would see your profile and you would say that who you are, they would see this is an authentic photo of the person that is claiming to be who they are. So anyone could just see if this is who the person is. So this is, a relatively simple mechanism. It requires blockchain because you have many companies and you have a big problem of trust between them, the manufacturers of the phones or the cameras, and all the social networks who wants to authenticate the data. So an example solution like this could bring huge value to the world. And it's here. It's not difficult to do. It's mostly, just integrate. Convince them that it's important, show them that it can be done today, and go and do this. So this is like the vision, solve problem like these, bring impact, that 70% of the profiles on Twitter would be authentic. Like if we could do that, we would change the world. So this is one example. I want to give you another example. Another example could be, how could a company, a social network that is incentivized to manipulate data for its own good, can convince the users that it's not doing that. Kind of like Mark Zuckerberg is telling us, we care about your privacy. Okay, right. We hear you, but you're incentivized not to care about my privacy because you make money off of it. So how can you prove to me that you are actually doing what you say you're doing and not just say, trust me, because we don't trust you? So one of the things you could do is run certain algorithms on a blockchain. And the great thing about blockchain is that it's provably verifiable by anyone. So you don't need to trust anyone. You can just run the smart contracts yourself and see that you get the same result. So for example, you could take, let's say, reviews on Yelp. Okay, Yelp is a social network. In a sense, people leave reviews there to find good businesses or restaurants to visit. Now, as you know, Yelp is incentivized to, have companies pay to hide their negative reviews. So the entire business model of the company is based upon fudging the numbers. Right. Like you go to Yelp to get honest reviews, yet they're incentivized directly to do the exact otherwise. So they could go and tell you, look, trust me, we're not doing that. Or if they really wanted to prove that they're not doing that, let's say that their business model was not based on fudging numbers and hiding data. So what they could do is they could put the reviews on a blockchain. So we could verify that the reviews are indeed there. And they could do the sorting algorithm that shows you the relevant reviews. This is the magic word. We decided that the negative reviews are not relevant because they paid us. So they can do the sorting algorithm on the blockchain in a way that a third party, anyone, could go and verify that they get the same results. And this would be a hard proof that they're not doing these things. So by embracing, this third party verification of what they're telling us that they're doing, they could regain the trust. And not by saying, trust us, but just by showing us, check us. Right. And I think that this is also a big way forward, but, they're scared. They're scared to do this. So it's going to be a slow process. And I think that the world is pushing them in the right direction. People are not tolerating, these things. And I know these cracks are, what's going to break down these huge empires, these cracks in trust. And there are, I don't want to say easy, but, viable solutions around it to give good proofs that you do what you say you do. Accountability, that's what's missing.
And you had a lot of really good points there, Tal. Man, and I just lost my train of thought again. I got to quit reading the next question while I'm talking because it's throwing me off. I've written multiple articles on the potential of blockchain. To me, blockchain has enormous potential to change the world in so many different ways. And seeing a project like Orbs and hearing what you are using as case studies and what you could, what could be done, you're preaching to the choir, in other words. I definitely think that you're onto something here. And one thing I wanted to ask is, how did you guys settle on the randomized proof of stake over other forms of consensus making?
Okay, so consensus is difficult, and it's difficult because there are inherent trade-offs when you try to solve the difficult problems like that. And one of those inherent trade-offs is speed, scalability. If you want to go to a company like Twitter, you need to work in the Twitter scale. And Twitter, they don't work at 20 transactions per second. Okay, they need something that is much, much faster. And on the other hand, you have decentralization or security. The more decentralized network it is, the more nodes you have, the more trustworthy it is. And usually these go against each other, because the more people involved in the consensus that you have, the slower this consensus is. Like put 50 people in a room, tell them reach a decision, or put 300 people in a room, tell them reach a decision. Right. So you want something that is very, very decentralized with lots of nodes, but on the other hand, something that's super fast. And randomized committees is, the magic bullet that gets you both. Because you don't have to kind of like compromise on one side, EOS, for example, like beautiful project, but they compromised on the number of validators. They have 21 validators. And that's, many people claim, is not decentralized enough. But it's very fast. That's their benefit. So what randomized committees can do, and you see more and more projects doing this, is the fact that you can have a very big, large list of validators, so you're very decentralized, but every time when you want to reach consensus, you take a randomized group, smaller group among them. And this randomization process is cryptographically secure in a sense that nobody can predict it. So basically you would get the security of the large group, but the speed of the small group.
That's absolutely brilliant. It's beautiful. I was digging through the advantages, and I saw that each virtual chain can choose its consensus model flavor, optimized for latency, throughput, fairness, and cost savings. What exactly does that mean for the business owner?
Okay, so I'll show you like a real business problem. And as we know, every distinct app has its own requirements. Usually you don't have like all the apps wanting the same thing. And I'll show you a good example. Take a look at Bitcoin. Bitcoin is a great application, a great decentralized application. And even when this application tried to make a decision on its consensus, for example, increase the block size, like we've seen how difficult this decision is. You know, there are so many parties that would be impacted by this, and they all have different needs. You know, the miners want large block rewards. They don't want more transactions, and the users want lower fees. So you have opposing interests. Now, the big problem when you have one shared chain, like Ethereum, for example, is you have that all these different apps are running together on the same consensus. So let's say that one app wants to have larger blocks because it needs one thing, and a different app needs something different. For example, slower consensus or bigger blocks. Usually, on a shared chain like Ethereum, they would either have to make this decision together, which doesn't make sense. You know, think about companies like Amazon, Apple, and Facebook. Like, do they need the same things? Would they be able to reach consensus among them? No. So the idea of virtual chains basically says that we're able to isolate the apps. So those isolated apps can make consensus decisions on their needs and tailor the consensus to what they want. For example, one app can say we want larger blocks because we need very high throughput. And a different virtual chain, different app can say, no, we want a slower consensus because we're holding a lot of value and we want more security over speed.
Right.
So, you know, by separating those needs to different apps, I think we can actually provide each app with a better solution.
That's great. How many different flavors are available?
Well, usually it's about tweaking parameters. So you could, you know, for example, play with trade-offs over, you know, how many validators are versus, you know, how fast it is or how expensive it is. You know, one of the biggest problems is costs. Like, and nobody's talking about costs. You know, right now, the value in blockchain for real businesses like Twitter is so vague, yet it's so expensive. You know, running something on Ethereum costs like 10,000 as more than running it on your own Amazon AWS server. So if you want to, you know, pitch blockchain, you need to give 10,000 the value, and it's very hard to give so much value. You know, like the use cases are very vague right now.
Right.
So one of the ways to go around it is to reduce costs. Like if we can run blockchain at twice the cost or 5 times the cost of centralized, it will be much easier to adopt. So what we're doing is we're allowing to tweak those parameters and get those reduced costs because you have, you know, different needs of security. You know, on Ethereum, for example, you put your life savings on Ethereum, for example. So you want 10,000 validators validating every block. Right. But if you're, you know, putting reviews on Yelp, maybe you would say 100 validators is enough, and it could be much cheaper.
Definitely. One of the factors one of the biggest factors that jumped out at me when I was looking at Orbs was where tokens can be kept on a proof of work base layer for added security without the performance and cost drawbacks. That seems interesting. So how would that work for businesses?
So the thing is that, you know, usually businesses would want to separate, you know, the tokens from their business.
Right.
Tokens are a means of payment, and usually you don't want to run tokens on your own servers, for example. So using, and you know, tokens are, you know, it's a financial system. And usually when you have, you know, a product, this financial system is not working at the same speed and not related to the, you know, utility of what you're trying to do in your application. So basically what we can do is we say, you know, there are financial blockchains out there like Ethereum. And if you have an asset that you want to create, you can create it on Ethereum. Use Orbs for something different. Don't use Orbs to create your own token. Like if you want to create your own token, do this on Ethereum. Ethereum does it very well. It's very well integrated. It has a very huge ecosystem. Ethereum is great for certain things. This is one of them.
Right.
You want a blockchain for the other utility parts of your application. You know, for example, putting reviews out there, which is something that is not related to tokens or tokenization. You could do this on Orbs, and it would run much, much better and much, much faster and cheaper. So these are the use cases that we specialize in.
Gotcha. Now, how can businesses have proof of work and randomized proof of stake?
So this is, like there's a huge battle between proof of work and proof of stake. And it seems that proof of stake is gaining, like in moving forward, but still, like the big, core Bitcoin maximalists would tell you that there's nothing better than proof of work. Like the only problem with it is it's inefficient. So one of the things that we're trying to break our head around is how can we use the benefits of both? And one of the cool things that we're doing is that we're mixing proof of work and proof of stake in a very exciting way. So let me show you what it is. So proof of work is very expensive and very inefficient because you waste electricity, but it has certain properties that are very difficult to imitate in proof of stake. One of these properties is called objectivity. Objectivity means that anyone looking at your system, anyone looking at a block and wants to be convinced like that the person who signed the block is indeed the person who could sign the block, they could do that without trusting anyone else. They could just rely on themselves to verify everything. And in proof of work, it's very easy to reach this objectivity. Why? Because checking and verifying the work is very easy. You could take the Bitcoin chain and on your own laptop, you could do all the verifications. It's going to be very easy to do. So proof of work is very objective. So the degree of trust there is very, very high. Proof of stake is a little bit more tricky. Now, if you go into this and you try to play the same game, for example, go to EOS and ask them for a block and tell them, I want to verify by myself that this block was signed by the correct stakers. So they would tell you, like, yeah, like these are the validators that were chosen. And then you would ask them, but who chose them? Show me the transactions that chose them. And they would show you other blocks that these same validators ran that chose their own validators. So it's kind of circular. It's much less objective. It's a bit subjective. It's kind of like, imagine an election that the party in power is running all the voting booths. It's kind of like that. So this is like one of the things that I dislike about proof of stake. Because it's a bit more subjective, the degree of trust is a little bit lower. So one of the things that we try to think is how can we take this beautiful objectivity of proof of work and embed it into our own system? And one of the cool ideas that we thought of is let's do the voting, the process that selects the validators in the proof of stake, and let's run this with proof of work. And this is exactly what we're doing. So proof of stake is kind of like an election. Everybody stakes, and then you tally out all the stake, and you decide who are the validators accordingly. Right. So what we do is we actually run this voting process on Ethereum. We don't run it on Orbs. And Ethereum is proof of work. Right. So it's objectively verifiable. And what it does is if you want to check that Orbs proof of stake is indeed honest, you get proofs from Ethereum. So you have like a third party running on proof of work that is guaranteeing that our validators are honest, that our proof of stake validators are honest. And this is beautiful. Right? And if you compare it to the election example that I gave you before, so instead of having the party in power running its own voting or running its own voting booths, you're basically bringing the United Nations, Ethereum in this case, like an uninvolved third party, and having them check everything. And I think this is very, very powerful. Now the question is, why isn't it too expensive? Because Ethereum and proof of work are expensive. And the reason it's not expensive is because you only do this for the staking. And staking doesn't happen quickly. It only happens when people shift stake. The applications, they don't run on Ethereum. The applications on Orbs need to be very skilled and very fast. We run them on Orbs. So the validators are very, very fast with proof of stake. But you know that they were selected honestly because proof of work did the selection process.
That's beautiful. Absolutely beautiful. Tal, this has been very enlightening. And I do have a couple of other questions. I wanted to circle back around to virtual chains.
Mhm.
Um, can you tell me more about the virtual chains and how they work?
Yeah, the idea behind virtual chains is the concept of isolation. And I want to show you why isolation is important by showing you an inherent flaw of public blockchains. So think about, the DAO bug in Ethereum. So, like everybody have heard about that. So what happened there? So what happened was that there was a security flaw in one of the apps. Like somebody created an app and this app had a vulnerability and somebody used this vulnerability to steal a lot of money. So basically, there were a couple of solutions of what to do about it, and the solution that was eventually chosen was let's roll back history of this smart contract.
Right.
Okay, so this is, like I understand this is a crisis, and you solve this crisis by changing history, and this makes sense if the crisis is big enough. But what happened to other apps on Ethereum at that time? Their histories rolled back as well. So because one developer made a mistake in their application, all the other developers running on Ethereum had their history reverted as well, which is pretty much insane. So now go to Twitter or Uber and tell them, guys, run on a system that a different developer, his mistake could cause your own history to be rolled back. Now, what would they tell you if you told them that this was an option? They would tell you this is insane.
Right. They're not going to do business with you.
Exactly. So the idea of virtual chains goes again exactly around that. Basically, it runs every application on its own virtual chain. So if there was a catastrophic security vulnerability, for example, and the community decides that it makes sense to roll back history, which is a huge thing to do, it's pretty much insane. But it could be if the application, lots of money was stolen, there was a huge, huge issue.
Right.
Rolling back history, for example, would not influence all the other apps. And this is crucial because the other model doesn't work in the real world.